Good evening, boys and girls. Tonight's lesson is called Add and Subtract Fractions with Like Denominators. Our essential question is, how can you add and subtract fractions with like denominators using models? Please make sure that you write this essential question down at the top of your handout. Let's look at our first problem. It says Miss Clark has the following pie pieces left over from a bake sale. She will combine the pieces so they are on the same dish. How much pie will be on the dish? So here it shows she has this much pie left over from one dish and this much pie from another dish. She wants to put them together. She wants to combine them. That means she wants to add this pie piece to this pie dish. So if I come down here and look at our model, I'm going to shade it in so that I can combine the pieces and see how much will be on one dish. So for this pie, we can see that it's cut into 6. So I have 3 pieces of the pie shaded in, and that's how much is left over. Now, on this dish, she has 1 piece of that pie left over. Now, if I want to show this in a fraction, I can say for my first dish, she has 3 out of 6 pieces left over on this dish. And for this pie dish, she has 1 piece left over out of 6 pieces. And if I want to put them together, I'm going to have to add. So I can add these two fractions because they have the same denominator, and as you can see, the pies are cut into the same sized equal pieces. They're out of 6ths. So really all I need to do is just add my numerators. I have 3 plus 1 is going to give me 4, and my denominator is the 6, so it just stays the same. That means my pie is still cut into 6 pieces. Now, I'm going to shade in my pie to match how much will be on that one dish when she combines it. So I have the 3 pieces from one dish, and now I'm going to add in that 1/6, that other 1 piece from the other dish. And you can clearly see that I have 1, 2, 3, 4 pieces of pie out of 6 pieces of pie. So how much of the pie will be on the dish? She is going to have 4/6 of a pie is on the dish. Now here we're going to look at our same pie dish. So remember that she had 4/6 on that one pie dish. So she has 4/6 of a pie, and it says suppose Miss Clark eats 2 pieces of the pie. How much pie will be left on the dish? So if I start off with 4 pieces of the pie on the dish, so 4/6, and Miss Clark is going to eat 2 of those pieces, which means that I'm going to take 2 pieces away, and so that's what my X is going to represent, that she took those away. So if I have 4/6 of a pie and I take away 2/6 of that pie, so I'm taking away 2 pieces out of 6 pieces, how much am I going to have left on the dish? Well, I'm going to look at my model. If you can see, I only have 2 pieces of pie left on that dish. So 2 out of the whole 6 pieces is left. And as you can see, if I look at my equation, the denominators are 6, so it stays the same for my answer, which means that I have the same sized equal pieces, and I just need to subtract my numerators. So 4 minus 2 gives me 2, and then my denominator just stays the same. 2/6 of the pie is left over. Now, I can put 2/6 into simplest form, and the way that I knew that right away is because the 2 and the 6 are even, which means they can always be simplified. So my GCF between 2 and 6, which means my greatest common factor, is a 2. So I'm going to write that my GCF is 2. Now I'm going to divide by 2, and I will get my simplest form. So 2 divided by 2 is 1, and 6 divided by 2 is 3. So in simplest form, 2/6 equals 1/3. Now you can only join or separate parts that refer to the same whole. Now, what that is saying is that we can only add or subtract fractions if they're part of the same whole. Now, it says, suppose Randy has 1/4 of a round cake. So here's his 1/4 of a round cake, and he has 1/4 of a square cake. Now, would we be able to say, in this case, 1/4 plus 1/4? In this case, we would not be able to add 1/4 plus 1/4 using these two models, because if you look at our 1/4s that are shaded, they are not part of the same wholes. They are different sized pieces. So yes, they equal 1/4, but they're not referring to the same whole. So we would not be able to add this 1/4 to this 1/4 because they're not part of the same whole. Now let's look at this model and let's solve the addition problem. We have a model here showing us an equation. In this fraction, we're going to write 1/4 because one part is shaded out of fourths. And we're going to add this 1/4. And we can add them because they're part of the same whole. The pieces are the same size. Now, 1/4 plus 1/4 equals 2/4. Because our denominators are the same, so we just make our new denominator a 4th. And we're going to add the numerators. 1 plus 1 gives me 2, and our model is showing this as well. So if I combined these two models together, I would have 2/4 when I combine it. Now, I know you're thinking what I'm thinking, which is 2/4 can be simplified. 2/4 is also equal to 1/2 because 2 is half of 4, and our model is showing us that half of the model is shaded. Now let's look at this model here. This model looks just a little bit different because it has a hole on the top. Now they're just putting this whole piece so that we can see how our fraction bars relate to a whole. So if you can see here, I have a fraction bar that's cut into fourths. Now if I had them all shaded, that would equal to a whole. But I don't have them all shaded. But I do have 4 parts. So they started and they want you to say 1/4 plus the 2/4 that they have shaded as well. Now, as you can see, if I have 1/4 plus 2/4, how many are shaded all together? That's right, there are 1, 2, 3/4 shaded in. Now, looking at our model and our equation, we have 1/4 plus 2/4, that equals 3/4. And that is what our model is showing us here. Now let's look at what this model is showing us here. We have our same whole piece. They're just saying that this is going to equal a whole if we had all of these 1/8 shaded in. So we can see that we have 8 equal pieces is what we started with, but what we began with, the shaded parts, was we have 1, 2, 3, 4, 5 out of the 8 pieces shaded. So that's what we started with. We started with 5/8. Now, this is showing us that we are taking away some of the eighths. We are taking away 1, 2, 3 eighths. So I'm going to subtract 3 eighths. And I want to see what am I left with when I subtract 3 eighths from 5 eighths. Well, the model is showing us that we have 1, 2 eighths left over. So 5 eighths minus 3 eighths is 2 eighths. Now my denominators are an 8, so my denominator for my answer stays an 8, and then I just need to subtract my numerators. 5 minus 3 is 2, so I'm left with 2 eighths. Now, I can simplify 2 eighths because both of the numbers are even, so I can always divide. Now, the greatest common factor between 2 and 8 is 2. So I am going to divide by 2 to get simplest form. 2 divided by 2 is 1, and 8 divided by 2 is 4. So our answer is 2 eighths, but 2 eighths simplified is 1/4. Let's look at another model. This model here is showing us that our whole is cut into tenths. So 10 tenths shaded would equal a whole. Now, first we have to see, what did they begin with? Well, they began with 1, 2, 3, 4, 5, 6, 7, 8. So they began with 8 tenths. And then this crossed out part is telling us that they took away some tenths. So they took away 1, 2, 3 tenths. So 8 tenths minus 3 tenths is our equation. Now, how many tenths are left when we subtract 3 tenths from 8 tenths? Let's count. 1, 2, 3, 4, 5. So 8 tenths minus 3 tenths is 5 tenths. Now, if you look at that fraction 5 tenths, I bet you're already seeing that it is equal to 1/2 because 5 is half of 10. So 1/2 is the simplest form for 5 tenths. Let's look at this problem. We have 4/5 minus 2/5. Now, our denominators are the same, which means they are part of the same whole. So we know that when we subtract, we are going to have the same denominator. We just keep it out of fifths. Now, we need to just subtract the numerators. 4 minus 2 is 2. So our answer is 2/5. Now, boys and girls, for this problem, I would like you to try this one on your own. So pause the video, work out the problem, and press play when you're ready to go over the answer with me. Okay, let's go over our answer. Now, I have 1/2 plus 1/2. Now, since our denominators are the same, our denominator is just going to stay a 2, just like our two denominators for our other fractions that we're adding. So we just needed to add 1 plus 1 is 2, and our denominators stay a 2. So 1/2 plus 1/2 is 2/2, and 2/2 is also equal to a whole. Okay, boys and girls, we have two equations here using fractions, and I would like you to try to solve these equations on your own. So we have 3/12 plus 8/12, and then we have 9/10 minus 3/10. So go ahead, pause the video, work out these problems, and press play when you're ready to go over the answer with me. Okay, here are the answers. So for our first problem, we had like denominators, which means we can just keep our denominator the same, and all we have to do is just add our numerators. So 3 plus 8 is 11, and since our denominators were both 12ths, we would have a new denominator of 12. So 3/12 plus 8/12 is 11/12. Now I know that 11/12 is in simplest form because 11 is 1 away from 12. Now let's look at our next problem. We had 9/10 minus 3/10. So we had to subtract here. Now since our denominators are both 10, all we needed to do was subtract our numerator. So 9 minus 3 is 6, and our denominator stays the 10. Now, did anyone put this in simplest form? I hope you did. Since 6/10, since both the numerator and denominator are even, we know that we can always divide. So, the GCF between 6 and 10 is 2. So if we divide our 6/10 by 2, we will get 6 divided by 2 is 3, and 10 divided by 2 is 5. So 6/10 also equals 3/5 in simplest form. I hope you got those right. Great job. Okay, boys and girls, here are the homework problems for tonight. You have these on your handout. Now, we would need to use the model here, and we also have our equation for numbers 1 and 2. And then for numbers 3 and 4, you don't have a model, you just have the equation. Now, please try to make sure that your answers are in simplest form. Don't forget also to assess yourself. Make sure to tell us if you feel like you're a novice, an apprentice, a practitioner, or an expert. Good luck on your homework tonight, boys and girls, and we will see you tomorrow in class. Bye!